Hey guys, this is Brady Daniels. You'll have to bear with me tonight as I got sick during finals week, like always. But here tonight to do my presentation on my paper. So I'll just get over to some screen share for you guys. Okay, hopefully you guys can see this. I decided to do my paper on the evolution of mule deer and white-tailed deer. The reason I chose this is because I'm a wildlife ecology major. I really enjoy being out in the mountains, and deer are one of my favorite things to go hunting for. And so I've done a few research papers on them before, and so I felt it only necessary to do one more on them in my college career. So uh, the title is The Evolution of Otocoileus virginianus, which is white-tailed deer, and Otocoileus hemionus, which is mule deer. In my introduction, so both of these are found in the Cervidae family because obviously they are cervids. The white-tailed deer, as we went over already, is Otocoileus virginianus, and it is also known as the Virginiana deer. And mule deer, pictured on the right side over here, is Otocoileus hemionus, and it's named for its large ears. So you can see these ears are much larger than that of a whitetail, and we'll go into some different morphological ways to tell which is which later on. So its ancestors, when the glaciers were abundant and the fertile soil, is when the deer ended up having what we know as a baby boom, or just a huge explosion of growth. Sorry, I'm going to be coughing quite a bit through this, but by the tertiary period, deer had already evolved the characteristics that they needed to in order to survive in the colder climates. Whether it be the characteristics be more hair or bigger fat deposits or larger bodies, as we'll talk about a little bit later. Evolution also brought a higher quality diet for the deer, and they were able to select for that throughout the changing seasons. And they also have evolved differently to help relocate food that fits their nutrient-rich diet instead of competing for stiff, strong forage like their ancestors had to. Also, evolution has enabled mule deer and white-tailed deer to make any landscape pretty much their home, which lowered competition and predation, since they were in less compact groups. That's why it lowered the predation, and that's also why it lowered the competition. There wasn't many individuals to fight for resources. They've evolved into two subfamilies, so New World deer and Old World deer. And the biggest difference between these subfamilies is the foot structure. The Old World deer, upper or proximal portions on the first and fifth metacarpal for the Old World deer, and that word plesiometacarpal is how I'm going to pronounce that. Sorry if I'm murdering that. And the New World deer are telemetacarpal, and that means that only the distal end remains on their foot structure. Some of the more obvious morphological characters are antlers, and they can be used for a variety of reasons that we've learned. The majority that they're going to be used for is they're going to be used in intersexual combat, which will be combat where the males are fighting each other for the right to have the females of their choice to reproduce with. They're otherwise for advertisement to show off to the opposite sex, which goes back to intersexual combat. But like I said, they're most commonly used or most known for their use of combat. Symmetry of antlers is a reflection of environmental stresses and physical change during development. One of the papers that I've done in past was on the symmetry and asymmetry of deer horns. And as they are, as it says here, in physical damage during development, in that research, it was noted that when they would fight in their intersexual combat, they would sustain injuries. And if the injury was on the left side of the body, the right horn would have an altered form. So it wouldn't be symmetrical. And otherwise, they would get injured on the left side and it would affect the right side horn. And if the body was injured on the left side or right side, it would affect their left horn. So they are opposites. Anyway, back to the hand at task. They are the only family that, the cervids that is, are the only family that has developed an elaborate process of dropping their dead antlers and then regenerating them. And that's caused due to a testosterone peak that's caused by circadian rhythms. And most of us know that to be sheds is what the dead antlers are. And sorry, individuals with the higher genetics are more likely to produce large antlers. And I mean, we can all guess that the ones with the larger antlers are going to have the more successful fights and the more wins, and they're going to be able to pass on their lineages more effectively. So the difference between the two's horns, mule deer have these forks up here that come off of the main beam. So we'll follow the main beam up. You have a brow tine right here, and it will split and fork, and then split and fork again. So this mule deer would be considered a 4-point. Some people would call it a 5 if you would count that brow tine. The white-tailed deer, however, it has its main beam the entire time. Come clear up and around this curve here. And then these splits are also points, but its main beam continues the whole time. There are no divisions in it, just growths off of it. Another thing that I looked into was the alarm behavior of both species. A lot of it has been developed due to humans and hunting. So we'll go into more detail. So some of the things are tail flagging and snorting, and those they use in their species to alarm others for escape or any other reason that they might need to get out. So there's 2 basic social units. There's doe groups and buck groups, and a doe group simply consists of does, and a buck group just consists of bucks, which are males and females. Buck is male, doe is female. And females were much more likely to show this alarm behavior because they are more closely together, because they're giving birth at the same time as each other. And it's kind of hard to explain, but the bucks are not as social as the females. The females are all together all the time. The bucks are by themselves. Sometimes they're grouped up. So that's where that comes from. More alarm behavior is more geared towards the whitetail, simply because the mule deer have a large rump and a small tail. So it's hard for mule deer to do tail flagging. But white-tailed deer have a smaller rump, and as you can see in this picture, it's alarming anything else around it by flipping up this tail, and it will bounce away, which we refer to as bounding or stotting or gait. So when it is alarmed, it will throw that tail up and it will start bouncing away. And its bounce will be dependent on the predation threat. And if the predation threat is very severe, they're not going to gate. They're just going to get out of there. They're going to sprint right out, and the noise from them sprinting will also alert the other ones. Another alarm behavior is snorting. It's used in two different ways. There's crucial situations when the discovery by the predator is certain, meaning that the predator has seen them. And then there's frequent situations where they can see the predator, but they have not, where the deer have not been seen by the predator yet. In a crucial situation where the predator has seen them, they're just going to explode out of there and they're going to scramble to get away. And like we said earlier, the gait is irrelevant at that point, and they just sprint right out of there. And also, as I stated earlier, the deer are going to hear the movement and the sounds, and they're going to get out of there too. Size and predation, as Pierce noted, multiple reasons why that has evolved. The deer have evolved larger bodies to avoid predation and to fight against predation. The males are more likely to move to habitats with a higher risk of predation. And the females, they are at a high risk of predation, even if they don't necessarily move to a high risk predation area, because they have their young that slows them down. And I think we've all seen that in real life. As we've gone over, they're sexually dimorphic, which means they're different in sizes and statures. The males are significantly larger than the females, and also the males possess horns, which can fight off predation. The females in this species do not grow horns. The body size for the female and the male is grown over the times that it's evolved to become larger, and that's just, like I said, to fight off predation. And the morphological traits for the males, the horns, are used a lot of the time to help fight off predation. And there's some pretty sweet videos on YouTube about this if anyone's interested to check them out. They've also evolved with migration and patterns. So one of the big things that they have evolved with is the ability to follow what's called the green wave hypothesis. And the green wave hypothesis is a hypothesis that says that when snow comes down, it accumulates in the mountains first. And as it covers up the grass on the top of the mountains, the deer will follow the grass line down into the valley until it's completely covered in snow. And then they'll do what they have to. They'll browse on shrubs and they'll pretty much scavenge for food, anything they can find. And then in the spring, once the snow starts to melt, it will begin to melt in the valleys first because that's where it gets warmer. And as the grass greens up, they'll time their migration or their movements to follow that greenness so that they can have the highest nutrient-rich foods at the best time available. So they will move up the mountain as that green grass grows. Also, there's state-dependent hypothesis, which predicts that the individuals in poor condition or those that might have high energetic cost will prioritize the green wave surfing to maximize energy gains. So, I mean,
it's survival of the fittest, and they're going to do whatever they can to survive. So if the grass is green and the weather's bad, they're going for it. As we said earlier, surfing the green wave can help find better forage for the deer and can influence the way that they migrate and their patterns that they have. But also, there's a learning hypothesis, and this is seen in a deer known as Jet. It was a study done by Matthew Kaufman, and it's about a deer named Jet. And Jet is a one-of-a-kind deer, and we'll go into it a little bit in a minute here. But her memory, since she was one of the older deer, her memory was used for the young that were dependent on knowing which way to migrate and which patterns to follow. So as I mentioned, Jet the mule deer was a deer that Wyoming Game and Fish had named. And she was one of the oldest deer in her herd. Her herd was not very old. And in their region, which I'll pull up a map here in a second, was growing, and they were putting in a lot of freeways and a lot of urban developments and creating a lot of bottlenecks. And so Jet had to adapt and evolve to do a 150-mile migration in order to get to ground suitable to winter them. And so here's where they are in the summer. And as the winter comes, they have to start migrating down this way. And as we get down here, this map is kind of zoomed out, but I actually made this map, so that was kind of cool. But we'll notice that up here, the bottlenecks, there's a few bottlenecks here, and a lot of them are fences and rivers and stuff like that. Private land that's been high fenced off so that the deer won't bother them. And then also there's some roadways down here. There's one of the biggest highways down around this area that they've put tunnels underneath so that they're more likely, or so that they're more able with less mortality to go underneath the freeway. And without Jet, the mule deer, evolving to know these things, they would have ultimately died off up here. They would have never found their way down this way. So the learning hypothesis is an extreme advantage in that case. So in conclusion, the evolution of both white-tailed deer and mule deer, they've created what is known to be an ideal body structure to survive in their everyday habitats. They've learned to surf the green wave and migrate to go find the most nutrient-rich forage to help them grow bigger, to help them grow better antlers, and in all, it just helps them survive. Evolution has increased the succession rate of sexual selection. It's increased the successfulness of avoiding predation and the ability to handle stressors. And those are my references. I hope that I've taught you guys something, and I hope that you found this more interesting than rambling. And again, I apologize for being sick, but that's just how it goes sometimes. So thanks, guys. We'll see you later.